Hey everybody, Mr. Bennett back here with a new set of notes. This is video number 2 in our motion units, and today we're going to talk about position versus time graphs. The name implies that we are looking at position, or an object's spot in space, as a function of time. So, the position is changing based on the time. That means position is my dependent variable. It's over here on the y-axis. And time is the independent variable. So a little reminder about your graphing. We need to make sure our variables are on the correct axis, and time is right here on the x. The slope of a line on a position v time graph, the slope of a line can help us describe the motion or the movement that is occurring with that object or that person. So we've got an example here. I've got 5 lines on this graph, and we're going to fill in 5 categories. Starting with, well, first of all, before we do that, let's take a look. On our y-axis, we have position 0. So remember, this is the origin. This is where we start. And then we're moving away from the origin or backwards from the origin. Time is increasing from left to right. So this is time 0 and time n, whatever that time happens to be. On the graph, there's 5 lines. Looking at line number A, right up here at the top, we have a flat line. Its position starts at a spot and it stays at that same spot as we move from side to side. So this means that there is no motion, no movement happening with that line. The other thing it means, look here, line E, same thing, except this one is behind the origin. So E also has, no motion. There is nothing happening with this object. It's got a flat line, and that is your indicator. There is a 0 slope or a flat line. No slope. Flat line. Here. So there is no movement with object A or E, but their positions are different from one another. They are different objects. Line B, right here in the middle, we have a very steep slope. So this is a fast object, or fast movement. It's got a high rate of speed. And we know that because we have a steep slope. So the steeper the slope, so if there was another line and it kind of went in like this, it would be moving faster than B because its position is changing at a high slope compared to your time line. So in a very short amount of time, we have a big position change. Okay, so high slope, and that can also be a negative slope. It doesn't matter what direction your slope is going. If you have a steep slope, it means you have a high speed or a fast object. Line D is the opposite of that. If you look at line D, we've got a very long slope here. So over a long time, we have a small, it's going to go from about here to about there. It's not a very big change in position. So this line D would be a slow object. And we know because we have a low slope. Okay, not much is happening. Opposite of B. Long, low slope, very, very slow object in relation to other things. Finally, line C, right here in the middle, it's the only curved one. It's kind of got this swoop to it. This object, we say this object is accelerating. It is speeding up over time. There's acceleration happening. And I know that because, look, your positions change slowly here, and then that position changes up, and you've got a very fast position change occurring here. It's got a very high slope if this line were to be carried out constantly. So acceleration, this one has a curved line. Okay, on a position versus time graph, and that's the big thing. You got to remember, it's position versus time. We're also going to be doing velocity versus time, so those slopes have different meanings. So take a look at these and remember what they mean. This is also in your textbook. You can take a look at this in class. And finally, at the very bottom, pay attention to changes in positive position versus negative position. Right now, all of these objects are going in a single direction. And that's your critical thinking question. What would it look like? How would you show a direction change on a position versus time graph? So take a look at that critical thinking question. Always, always, always make sure you do those. If you have questions, I will see you in class. Or you can leave it in the comments.